Okay, so we're going to take our notes today, get them done, and then when we're done with these notes and examples, you should be able to head on over to Big Ideas and get started on 10.5. Just think we're over halfway through the lesson. Today's topic is angle relationships in circles, and the objective I have for you is that students will be able to find angle and arc measures and use circumscribed angles. Remember, the previous section was on inscribed angles. That's inside the circle. But now we're going to talk about angles that are formed on or outside the circle. So the first we're going to start with is a tangent and intersected chord theorem. If a tangent and a chord, so here's your tangent A, and here's your chord AB. If a tangent and a chord intersect at a point on the circle, then the measure of each angle formed is 1/2 the measure of its intersected arc. So, I like to color code. So there's my chord, there's my tangent, and then this is the arc that it intercepts right here. Okay, so actually there's two different things you can write here. First thing you can write is that the measure of angle 1, the red that I just highlighted, is equal to 1/2 times the measure of arc AB. But you can go further. Hope this is enough distinction. This is orange. You can also say that the measure of angle 2 is equal to 1/2 the measure of arc ACB. And so it goes both ways. Hopefully that is clear enough for you to see. So we'll do an example where we can find this. Line M is tangent to the circle, and we're going to find the measure of each of these. So the measure of angle 1 right here, as you can see, is going to be 1/2 of this arc, which is 130. And so that's going to be 65. On this one, we're looking for KJL. So you're starting here, and you're going around KJL. Well, again, I'm going to color code. Here's my angle in blue, and this angle is 1/2 as much of this. So that means that twice 125 will give you the arc. Okay, that's how you use that theorem. Now we're going to move on to the next concept. While you digest that, and you'll be able to practice it in Big Ideas. Intersecting lines and circles. Just like we talked about tangents, internal and external common tangents, we also have 3 situations here. If 2 non-parallel lines intersect in a circle, there are 3 places that they can intersect. 3 and only 3. They can intersect on the circle, they can intersect inside the circle, or they can intersect outside the circle. Those are the only 3 possibilities. So we're going to draw these lines. Okay, use red and blue, make sure they stand out. Right on the line would be 2 tangents that are exactly tangent at the same point. Okay, if they cross somewhere inside, it looks like that, where their intersection point is inside the circle. And then last, say they, one of them's over here, and one of them is over here, then they are intersecting here outside of the circle. So on the circle, inside the circle, outside the circle. Those are the only three ways that you can get three intersecting lines. So we have a theorem about this. If two chords intersect inside a circle, that's this one here, then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. So angle 1, okay, you're basically going to average them. You're going to take this arc and also the arc of its other vertical angle. You're going to add them together and divide by 2. So the measure of angle 1 is equal to 1/2 when you add the measure of DC arc plus the measure of AB arc. So you're basically averaging those. Okay. Now, if I want to find angle 2, then I'm going to do the red parts. I really, really do hope you're color coding these. It will really make a difference in how much it sticks in your brain. So then the measure of angle 2 is going to be 1/2 these two average. So it'll be the measure of arc AD plus the measure of arc BC. And then that'll be red to correspond to those. We're going to, of course, use this theorem in a couple of examples right here. We're going to find the value of x in number 2 here. So x intercepts this arc and this arc. So it's going to be 130 plus 156, all divided by 2. And that's going to be 143 degrees. You can check with your calculator, but for the sake of time, I'm throwing that out there. Now this one, it's giving me the angle, and I have to figure out other stuff. So I want to find y. This is 95, this is 102. I'm looking for y, and I should probably also be able to figure out some other stuff here, but it looks like this arc here plus this arc here oh, you know what's missing here? This is supposed to be labeled 78. It doesn't say it's a diameter, but in the picture I accidentally left that out. So if these two arcs are these two central angles are 78, then that should be 78 equals 1/2 times y plus 95. So if that's the case, then we should just be able to use algebra to solve it. I'm going to multiply both sides by 2 to make that go away. And so I get 156 equals y plus 95. And then I get y equals, subtract, 61. Okay, so I'm going to turn the page here. Hopefully you have that all filled in. We just have a little bit more on this side. Okay, but again, these things that we're going to do are pretty straightforward. We're going to find x. X is right here. The other arc is 97. So if they intersect inside the circle, then 110 is equal to 1/2 of these two arcs. This 110 is equal to 1/2 of x plus 97. So I'm going to multiply both sides by 2 to get rid of that half. I'm a little tired. My head's not working super great. So let me see what 220 minus 97 is. It's 123. Again, very straightforward. Just find x. Now, this one over here is slightly different, right? Because you're going to have to figure out this angle first, and then you can figure out what x is. Well, yeah, that's basically it. So x is, no, not, yeah. So first we'll call this, what should we, for angle, let's call it j. I feel like calling it j. So j is equal to 1/2 55 plus 75. Okay. So 55 and 75 is 130. Half of 130 is 65. So that means if this angle here is 65, and they make a straight angle either here or here, then it has to add up to 180. So you get x equals 115. So remember, you have to answer the question being asked, not necessarily what you find on the first step. Sometimes they take 2 steps. Now we have a second theorem, and that's it. Those first examples were all if the lines cross inside the angle. So this one is outside the circle. I misspoke. I just said inside the circle. Inside the circle, not the angle. Okay. So here we go. If a tangent and a secant, 2 tangents or 2 secants, intersect outside a circle, then the measure of the angle formed is 1/2 the difference of the measures of the intersected arcs. So this is very similar to what we did. So you could have these 3 situations. You've got a major arc, and you subtract the minor arc to give you the first angle. That's a tangent and a secant. Same thing here. This is 2 tangents. Major arc minus minor arc, and then divide by 2. Again with this picture, major arc, subtract minor arc. To get that angle, it's 1/2. So you see how it's almost exactly the same as the other one? If they intersect inside the circle, you add and divide by 2. If they intersect outside the circle, you subtract and divide by 2. So what I want you to do right here is write angle equals 1/2 outer arc minus inner arc. And if you're color coding, make that blue, make that red. And if you want, you know what, while I'm at it, let me just go ahead and angle 1, angle 2, angle 3 as they intersect. Okay. I also want you to write right under here a little bit more. The measure of angle 1 is equal to 1/2 the measure of arc BC minus the measure of arc AC. And then here, measure of angle 2 equals 1/2 the measure of PQR arc minus measure of PR arc. And then here, the measure of angle 3 equals 1/2 measure of XY arc minus the measure of WZ arc. Sorry, I'm squishing you a little bit. You probably can write a little bit smaller than me. Again, I'm just going to throw in a little bit of color coding to make this stick. Here's my green. The measure of the arc is green. The major arc comes first, and then the minor arc is subtracted, and it's always the 1/2. So with these notes, you should be able to solve any problem. We have 3 examples here. I'll run through them fairly quickly with you. One vocabulary word here is circumscribed angle is an angle whose sides are tangent to a circle. So it is possible to have it exactly tangent to a circle. We're going to find the value of x here. Here's your major arc. Here's your minor arc. So x equals 1/2, 178 minus 76, because they intersect outside the circle. So that's 102. So let's see, that's going to give me 51. Major arc minus minor arc. Number 5. I've got the angle, and now I'm looking for this arc. Still going to be the same formula, only instead of x, it's 30. So 30 is equal to 1/2 a minus 44. Make sure you use your parentheses. So to get rid of the half, I'm going to multiply both sides by 2. And then I'm going to add 44 to both sides. And I get 104. Last but not least, obviously, we're going to do the value of x here. And this one's going to be slightly trickier. Okay? So this is an inscribed angle, which means EF is going to be 2x. It's going to be twice as much. This is what makes it tricky. I've got this angle here, and I know that these 2 lines intersect outside the circle, but I really don't know what this one is. However, what I do know is that this one here has to add up to 2x. So, I'm sorry, to 360. So total, the orange one is 360 minus 2x. If that angle is x, this is twice as much, and this is all the rest of the circle. So now what I can do is write an equation with this 30 and x's, and watch this, it'll be, here's the theorem. 30 is equal to 1/2 the difference of these 2. So this is 360 minus 2x, and I'm going to subtract 2x, and I should be able to find it. I mean, that's it, because this is the big orange arc, and this is the little black arc. Now I can combine some like terms here. I'm going to multiply both sides by 2, so I get 60. That goes away. And then this is going to give me 360 minus 4x, because those can be combined. So I'm going to take away 360 from both sides. Divide by 4. And I get 75. And that is the end of your notes for this. You should be able to go straight on over to Big Ideas, start on 8.5, and definitely let me know if you have any questions.